Let's talk about internal forces. So far, most of the forces that we've seen in statics have been external forces, except when we looked at trusses. The forces that were in tension and compression were inside the structural elements, but we can expand this to other elements that are not in trusses. Let me explain what I mean. So when we look at these internal forces, what we have seen before is that in a truss, right? Let's say that we have a truss that is something like this. Right? If we were using, for example, the method of sections, what we do is we take a cut on that truss, right? So now when we take the cut, let's say on that line, the forces that we're going to be drawing in the elements are going to be now internal forces. So let's say that I have a force over here, another force over here that are external forces. Those two forces are forces applied to the structure. And when I make the free body diagram of the left-hand side of the cut, we're going to see something like this. I'm going to see a little piece of the element, a little piece of the element over here, a little piece of the element over here. This is an external force because it's applied to the structure. The support reaction forces are also external forces, right? But then I'm going to change the color here to red. We're going to see some forces that are being that are unknown, right? And they are inside the element. Let's put it that way, inside the element. Those are the internal forces, and in this particular case, they're either in tension or compression. So these are actually what is called normal forces. Normal forces, right? And they're either in tension or compression. Now we can talk about something more general, right? Let's say that now we have a beam. So in general, let's say that we have something like this. We have a beam that is fixed in one end, free in the other end, right? And let's say that we have a force at the end of that end that looks something like that. Is at an angle. Now what I'm going to try to do is I'm going to cut, same thing that we do with the truss, right? I'm going to cut it, let's say, let's use a different color. I'm going to do my cut right here in the middle. Okay. And when I do that cut, I'm going to start by drawing the right-hand side of that beam. So I'm going to do a free body diagram of the right-hand side. Let me do it all the way over here. So I'm going to see this part of the beam. I'm going to see that external force being applied right there. But then we're going to see a number of forces on the cut. We're going to see something that is called shear force, which is something that is perpendicular to the element. We're going to see our normal force, which is similar to what we've seen in trusses. And we're going to see a bending moment. So this over here is also something that we're going to see if we cut that element. So the moment, the shear force is usually expressed by a V, and the normal force is usually expressed by an N. Okay, so once again, this is my bending moment. This over here is my shear force. We give them name because when you actually do the design of these structural elements, these particular forces become very important. And this over here is my normal force, right? Normal force. All right, so now what's going to happen when I do the diagram at the other end? So let's say I'm going to draw the other part of the element over here. Well, in my reaction, I'm going to see what I expect for my reaction forces. So it is a fixed support, so I should have two forces in a moment, right? So if this is element A, this is going to be my AY, AX, and my moment at A, right? Nothing new. But in terms of my internal forces, I should see something that is of the same magnitude but in the opposite direction. So once I put these two parts together, those forces will cancel out. So my normal force would be something like this. My shear force should be something like this. My bending moment will be something like this. And those are my internal forces, right? So once again, is kind of an expansion of what we've seen in trusses, where we're now looking at something more general. And we see that it's not only the normal force that exists in the elements, it is also a shear force and a bending moment. All right, now one of the important parts of this concept is to understand the sign convention. And let me explain that in a slightly different way than just saying that it's a sign convention, okay? When I put the title here, a sign convention, but let me explain that. So when we looked at trusses, we said that that our default was going to be elements in tension. We're gonna treat those as positive, right? We're gonna basically gonna say that our default is to have the element. So if I have an element right here, right, and let's say we're only worried about this side over here, right? And I say, I'm going to treat this as my assumption. My assumption that this is in tension, so that's going to be my assumption as the normal force. And that still stands, right? And we said that in this case, we call this tension, right? It's going to be tension, right? By the way, this is my left-hand side of that cut that we did on the top, right? So this is the left-hand side of that cut. Now, in terms of the shear force and the bending moment, we don't have names like tension and compression. So what we do is we replace those with signs, positive or negative. So for me, it's useful to think about it that way. What do I mean by that? Well, let me do again that element, and I am going to do only my shear force. Remember that we only have we don't only have shear, but we also have my normal forces, and we have our bending moment, right? But if I only do my shear forces, so this is for shear, this is for my normal force, what I'm gonna see is by default, if my left cut is going down, I should do that in red. Left cut is going down. My right part is going up. When I call this positive shear force. Okay. Of course, if my left is going up, my right is going down, then that will be a negative shear force. All right. Now let's look at the bending moments. So when we look for moments, we're going to see that my default as positive is going to be something like this. On my left-hand side of my cut is going to be something like this. This is my positive moment. By the way, this is V, same. On my right-hand side is going to be something like this. So this is by default my positive bending moment. Now, I'm not saying that when we write the equations of equilibrium, we should change the way that we write the equations of equilibrium, right? That's not what this says. What this is saying is, since we don't have names like tension or compression for shear forces and bending moments, we replace that for basically a sign, a positive or a negative. So whenever we have the forces going as drawn for your shear force, we call that a positive shear force. And whenever we have the moments drawn like that, that becomes a negative shear, a positive bending moment. Why is that important? Because when you do the design of a structure, that direction of the bending moment and the shear force and the normal forces become important for design. So it is different to design an element that is in positive moment than in negative moment. In the same way that you might design differently an element that is in tension or in compression.